Okay, for the series below, use appropriate tests to find out whether it converges or diverges. For convergent non-positive series, so for non-positive series, you should determine whether it converges absolutely or conditionally. So we need to check whether this is positive or non-positive. This is clearly non-positive. Okay, so we need to determine whether it converges absolutely, converge conditionally, or diverge. So for non-positive series, what I will check is this first. I will just check whether the sum of this converges. Okay, because if this converges, it means it converges absolutely. Okay, sorry, this means this converges absolutely, and we just need to stop. Okay, if yes, then conclude that sum of sine n over n square converges absolutely. If not, then check whether the sum of sine n over n square converges. If this converges, then if yes, then it means the sum of sine n over n square converges conditionally. If not, then the sum of sine n over n square diverges. Okay, so first we check whether the sum of absolute value of sine n over n square converges. If yes, then we can just conclude that this converges absolutely. If not, then we check again the sum of sine n over n square converges or not. If yes, then this means sine n over n square, the sum, converges conditionally. If not, it means that the sum of sine n over n square diverges. So this is how it works. So first, we want to check whether this converges. So what test should we use? Can we use limit test? If we use limit test, then what will happen? Limit n tends to infinity of absolute value of sine n over n square. This will be 0 if this one is by using squeeze theorem. Okay, so from limit test, there is no conclusion. So cannot use limit test. For integral test, I will skip this because when I see this, even if this satisfies the integral test conditions, we need to integrate the absolute value of sine x over x and x square, and I don't think this is easy. Okay, so I will not check anything from integral test. I will just skip it because this looks difficult. Okay, that's the only reason. Then how about comparison test? Can we use comparison test? And the answer is yes. Okay, so let's try comparison test. So we need to compare. Okay, we need to compare sine n over n square with something else. But we know that this absolute value of sine n, this is less than or equal to 1, right? And absolute value of n square is just n square, so I just copy. So we have this. We have 0 is less than or equal to sine n over n square, absolute value, okay, less than or equal to 1 over n square for all n. From 1 to until infinity, right? So since the sum of 1 over n square, n starts from 1 to infinity, converges by comparison test, we have the sum of the absolute value of sine n over n square converges. This means the sum of sine n over n square converges absolutely. Okay, done. So yeah, this is the solution.